Hello Internet, my name is Quinn and this is Blondihacks. I'm tinkering with the shaper this week. It's got one big problem and a whole bunch of little ones. I want to get this thing as fighting fit as possible because I have a lot of projects I want to do with it. Also because it's 65 years old and it's not going to die on my watch. So let's go. Literally since the first moment I turned on this shaper for the first time, something was bugging me about it. It really felt like maybe it was running backwards. It's supposed to be faster on the return stroke, and it seemed like the opposite might be true. I spent more time than I'm prepared to admit staring at it trying to figure this out because it seemed like it might be running backwards, but it was also sort of a two faces and a vase thing, like it wasn't 100% clear that it was running backwards, and the evidence suggests that it's running in the correct direction because there's an arrow on the drive pulley and the machine is clearly running in the direction of that drive pulley. So it has to be correct, right? I haven't talked about this until now because it's been nagging at me, but I wasn't sure until I was certain that there was something wrong. I didn't want to mention it in any of my shaper videos up until now. I figured there had to be some third variable I was missing. How could that arrow be wrong? Then I got to think, it's weird that the arrow is on the inside of the pulley. Why would Atlas do that where it's hard to see it? It would be so easy to put it on the outside where it's easy to see. So then I started searching online for pictures of other Atlas shapers, and most of them have the factory drive belt guard still installed, but some of them don't, and on those ones, the pulley is flipped from mine. In fact, in all of the pictures I found, the pulley is flipped from mine. So there you go. My shaper's been gaslighting me this entire time. It's like that old sitcom joke where the characters get to a T-junction and they go the wrong way because the sign is old and it's fallen down around one nail, and so the arrow is now pointing the other direction. I think that might be what's happening. The pulley was fairly tight on there. It clearly has not moved in a long time. So at least the previous owner, maybe multiple previous owners, possibly decades, that pulley has been on there backwards and this machine has been running backwards. Curses. It's been running backwards at least as long as this motor has been on it because whoever installed that motor was clearly similarly fooled by the arrow and wired the motor to run clockwise. Well, clearly what I need to do then is get into this motor and reverse it. Now, reversing single-phase AC motors can be very, very easy, or it can be impossible. There's an entire range of possibilities. But let's just confirm, as you can see, the motor is running clockwise, and I need it to run counterclockwise. I'm going to run that footage again, though, and this time I want you to listen. You hear that click when it started? Now, when I shut it off, listen again. Another click. That information is very, very important, as you'll see in a minute. Regardless, reversing any AC motor generally involves getting into the wiring panel, and typically there's going to be multiple posts in here, and the posts are often labeled, and so you can easily see which wires to swap. Or if they're not labeled, then on the back of the panel there will be a wiring diagram. Curses. Well, this just got a whole lot harder. This is a GE Type KC motor, and lots of interweb searching revealed no GE KC motors that have a post configuration like this inside them. So this is a mystery. We're going to have to get serious about this if we're going to reverse it. What this means is we have to disassemble the motor and trace all of the wiring in order to know which two wires to swap to safely reverse this motor without damaging anything. Remember those click noises that I showed you earlier? That means this is a centrifugal switch motor. What that means is there's two coils in there, a start coil and a run coil. And the start coil is smaller, and it gets the motor turning. And then once it's spinning, that centrifugal switch disconnects the start coil and the motor runs only on the run coil. Because of that, you have to be absolutely sure which two wires you're swapping, because if you do it wrong, the motor can end up running on the start coil and you'll burn it out. You'll also find some online guides that tell you to just put an ohmmeter on all of the wires and find the two coils. Again, if you haven't disconnected everything inside the motor, that will not work. You cannot measure resistance in circuit on anything. But first we have to get into the motor, which necessitates removing the pulleys, and that one's been there quite a while. Nope, something's gonna break. All right, a little tappy tap tap. Sometimes some shock forces can break loose a stuck fastener and or pulley. And Yeah, no, that's gonna break something. All right, time for the smoke wrench. Try to do this without hitting the bearings on the motor with the heat. You don't want to smoke all the grease and or oil out of them. Doesn't take much heat usually to break something loose in this case. A little bit of tappy tap tapping as well, again, to help shock that set screw loose. And there she comes. Good old smoke wrench. Can't be stuck if it's a liquid. Result. With the long bolts pulled out of there and the pulleys off, now I can pull the front case off the motor, pull the rotor out. Do this carefully so as not to scratch up the enamel on the coils. And there she comes. That U-shaped copper thing at the bottom is the centrifugal switch that I talked about, so that confirms our suspicions on that. Now, looking at the coils, you can see how there's one coil with big thick wires kind of intertwined with a second coil made of much thinner wire. And this second coil is the start coil. So that also confirms that this is an asymmetrical coil motor. Some small motors will have two coils the same size, so it doesn't matter which coil the motor ends up running on. But in this case, we have to correctly identify the start coil. And as is typical, there will be a bunch of wires that go down from those posts and disappear into the coil pack. And we need to know where all four of those wires go. We also need to know for sure that all four of the coil ends are accessible. The two coils will be joined together at some point because they share a live or a neutral connection, and sometimes that junction is down inside the coil pack, in which case the motor is not reversible. We have to be able to access both ends of one of the coils independently. This motor also has this little widget attached in line with the live wire coming in on the AC. This looks to be a thermal cutoff switch. That's why it's mounted on the outside case of the motor facing outwards so it can cool off. Nice little safety feature there. So now I can figure out which of the colors of the wires I need to check to try to find the ends of the coils. One of them is in line with the start capacitor, so that's almost certainly the start coil, but we need to check to be sure. And then the other two wires that disappear down there are probably the run coil. But to be sure, we have to check them with the ohm meter, and now we can disconnect everything from all the posts so we know all the wiring is separated, and we can measure the resistance of the coils out of circuit. So I checked the first one and it's 2.1 ohms. The second one is 8 ohms. I then traced all the wires and drew out the schematic. The three black dots in the middle are the wiring posts, and this is the schematic of this motor. You can see the U-shaped centrifugal switch in the bottom left-ish corner there, and you can see a 2 ohm coil and an 8 ohm coil at the bottom. The 2 ohm coil is the big one, that's the run coil. The smaller diameter, higher resistance coil is always going to be the start coil. The way a motor like this starts is the start coil is wired in series with the start capacitor, which pushes that coil 90 degrees out of phase, so that kicks the motor off in the desired direction, and then once the speed is up enough, it disconnects that centrifugal switch, which pulls the start coil out of the circuit, and then it's running only on the run coil. To reverse this type of motor, we need to swap the phase of either coil. Either coil will work. The trick is, both ends of both coils may not be easy to swap, so just do whichever one is easier. In this case, as you can see, if I swap the yellow wire and the dark green wire at the posts, that will swap the phase of the run coil. The start coil would be difficult to swap because the red wire is soldered to the bottom of the centrifugal switch, and I would have to swap this black wire here that's on the opposite side of the mounting posts from the red wire. So very difficult, clearly not what the manufacturer intends. They clearly intend you to swap the run coil. Now this is just for this particular kind of motor. There are a lot of types of single-phase AC motors, and three-phase motors are different again. So you really have to know what type of motor you have, and you really need to know exactly where all those wires go. Don't just start swapping things, and don't just start measuring resistances of things in circuit. That will tell you nothing. Quick aside, because someone's going to comment, yes, there's some janky old crimp connectors in here. Someone's been in here before. Normally I would replace those, but there's not enough slack on these wires to risk cutting these off. So I'm just going to fix them up and put them back in. There are a lot of online guides and forum arguments about reversing AC motors, and many of them are confusing and or flat out wrong. I'm going to link you to the good one over at woodgears.ca. Matthias, you probably know his channel and his content. He's got a great website with lots of great information on clockwork woodworking and related things, but For whatever reason, he also has the internet's best guide on all the different types of single-phase AC motors and how to identify them, how to reverse them. So I'll link you to that below. Meanwhile, I'm swapping the dark green and yellow wires, as I said, and I also cleaned up the contacts with my vintage Radio Shack contact cleaner. I wish you could still get this stuff. It's the best. And now we can put the motor back together. When reassembling the case, make sure that you get the oilers lined up so that they're both pointing upward. This is an oil lubricated motor, but you might have sealed bearings, in which case it doesn't really matter, or you might have greased bearings, but either way, if the lubricators aren't pointing the same way, you might not be able to lubricate the motor. Fun little bit of archaeology here. This motor bracket has been brazed up at some point. Someone did quite a competent repair there. As I was reinstalling the start capacitor, I noticed the back of it actually was completely broken off. This has clearly been shattered for a very long time. I'm not sure how that happened, but I guess the plastic was very old and it dried out, but it was still working. And well, I'm going to obviously put a new one on, but I'm going to have to order one. I can't get that locally. So look, I'm not going to say I definitely super glued the back of that on and ran it that way for a week while waiting for the replacement, but I'm not going to say that didn't happen. All right, moment of truth. Is it reversed? Yeah, so you heard two pops there. Let's look at that again. The first pop was the switch exploding, and the second pop was the breaker blowing on my bench outlets. Well, that's why we have breakers, folks, to protect us from ourselves. So what actually happened here? Well, first of all, this poor old switch that was installed on it gave its life for the cause. Contacts vaporized and the plastic melted. That may have saved the motor, honestly. I looked back at my photos of the wiring before I touched it, and I immediately knew what I had done wrong. When you're swapping the wires on the coil, make sure you're swapping only those wires. I absent-mindedly swapped both the black and the yellow from one post to the other post. I swapped all of the wires on the relevant posts. You want to swap only the two wires, obviously. I did all the book learning right, but when it came to actually do the job, I borked it up. I went in there and fixed the mistake, put everything back the way it was supposed to be, and now we find out if I have fried this motor. And I have not. Look at that. It is now running counterclockwise. That necessitates a double fist pump of Imperial Victory because I have not fried this motor. Well, since I'm doing all of this wiring work anyway, I might as well take a look at the rest of it. Now, this hole right here in the casting is where there was originally a little switch installed. What Atlas did was ran one of the motor wires up inside the casting to this location through a switch and then back down to the motor so that the operator had a convenient motor power switch right here by the clutch control. Really nice idea. On mine, this switch was long gone. There was a blanking plate shop made over top of that, and then someone had put that light switch in that you saw earlier. But looking at photos of other people's Atlases online, you can see two different kinds of switches were used. I think probably the one on the left is earlier and the one on the right is later. And the reason this is interesting is because inside this opening, the space that exists for that switch is very, very shallow. There's actually less than ½ inch of depth because the main bowl gear for the shaper, believe it or not, is right there. Like, it is very, very close to the back of that switch, and there is no depth in there. So I have a theory that maybe Atlas was originally using these little switches. This switch has to be tiny in order to fit in that space. That maybe wasn't up to the task of switching 6 amps all day long, and maybe they then went to these later switches. Because if you look, this later switch has a cast boss that's mounted to the main casting to add depth for this switch. I saw a number of machines with this type of switch with that extra depth added. So I think I'm going to need to do something like this because, believe me, I looked. There is no modern switch that can handle 6 amps at 120 volts AC that is anywhere close to shallow enough to fit in that casting hole. And yes, I could add a low voltage switch and a motor contactor and wire all of that up, but that's a lot of extra complexity, and I want to keep it simple like Atlas did. All the modern switches are around 1 inch deep, and you need at least another ½ inch behind that for the wiring and the connectors. So I went over to CAD and I designed this little guy that'll act similar to that cast iron boss that you saw. It'll give me the depth I need. There's this rectangular hole in the bottom that's going to hold the body of the switch, push it out far enough to get it away from the bowl gear. Now, this would be pretty tricky to machine, but this is a perfect job for 3D printing. So I 3D printed a few samples of the first couple of layers until I got the fit just right and the shape just right. And you can see that the bolt holes, amusingly, are not in line in the casting. One of them is offset quite a bit. There's no reason for that other than it's just not lined up. So I suspect those were drilled by hand, probably in haste in the factory. But the idea is the switch will mount inside there, and then I can bolt this fellow on to the front of the casting, and there should be enough room for the wiring. Now, even with this, though, it is going to be tight in there, let me tell you. For the wiring, I actually talked this over with my patrons, and the consensus was this is the right stuff to use. This is SOOW cable, and that double O is important. What that means is the jacket and the insulation are both oil and gasoline resistant, because these wires are going to be running inside that casting, and it is very oily in there. There's grease and oil flying off of that bowl gear every which way. It's literally, like I said, millimeters away from that bowl gear. This is 3-conductor 14 gauge, which is overkill on both accounts, but it's what my local hardware store had, so I'm going to use it. But the importance of that double O is going to come into play here because this cable is much too thick to go down inside behind that bowl gear. There is not enough room for it. So I'm going to have to pull the conductors out of this and use them naked, as it were. So the insulation on the individual conductors is also oil resistant in this cable. And I am going to have to fish this stuff down here behind that bowl gear and get to the back of that switch. Before I stick my hot dogs in that meat grinder, rest assured that it is unplugged, and also I've removed the drive belt, and also I've double unplugged it. Yeah, I'm as nervous about sticking my hand in there as you no doubt are watching this. But this was very difficult, honestly. There's so little space in there, I can't even get my fingers around behind that bowl gear where the wiring has to go. It is that tight in here. When they did this at the factory, they have to have put the wiring in first. There is no possible way they did this after the mechanism was installed. And if you're worried about that wiring being safe in that environment, remember that the factory 1960s wiring was almost certainly fabric insulated, so this is certainly better than that. Now, to hold that wiring in place, there are these 2 holes in the casting. These might have been for wiring clips originally, I don't know, but I'm certainly going to use them for that. They're kind of in the perfect place for some clips on the inside to hold that wiring tight against the inside of the casting. Which is not to say it's easy to get them in there. I could get the bolt in and I could just touch the end of the bolt with a finger. So to get a nut on there, I ended up super gluing the nut to a glove, and that allowed me to fish it down in through the switch hole to get the nut started on there. I was able to get a wrench on it once it was started, but there was no way to start that bolt from the other side because I couldn't get my hand in around the bowl gear to the back of the casting. The bottom clip was easy, there was plenty of room in there. It was just this top one that was very tricky. But now I can get my switch wired up. And in case you're wondering, at the other end of this wiring, the wiring goes down into the bottom of the casting and then out the back. And at the back, there's a standard electrical clamp strain relief connector there. So I ran my cable through that and reused the original factory strain relief. Having done this now, I think probably an easier way to do this would actually be from underneath, because the bottom of this casting is open to the floor, as it were. So that would involve unbolting it from the bench and lifting it up in the air with the hoist and then setting it down on some cribbing or something so you could get in underneath it. But I didn't know how hard this was going to be, and I was kind of committed to this method, and it would have been a lot of work to get out the hoist at this point after having started with this approach. So I managed to make it work, but if I had to do it over again, I'd probably lift it up. Down in the bottom of the casting, there's plenty of room for the wiring to lie down underneath there, so I didn't need a clip along the bottom anywhere. I ran the cable out the back, as I said, and then I decided to install this little junction box on the back to join all of this together. I don't know how Atlas did this. I suspect they probably made this junction inside the motor wiring, but I didn't really like that, so I added this junction box. And I am not going to show you how I made all the connections in there, because one thing you learn having a YouTube channel is that electrical makes everybody mad. So just imagine what's inside that box is exactly how you would have done it. Moment of truth. Does she chooch? Oh, it's chooching. And there she goes. Look at that. That is excellent. I think it's fairly clear now that it's running in the correct direction as well, so that's pretty satisfying. That was definitely the right thing to do. And if you're worried about the machine being damaged in some way from it running backwards, it really isn't. I mean, it's fine. It's been running that way clearly for years. The only problem with running it backwards really is efficiency. It's going to be much slower because the cutting stroke is supposed to be slower than the return stroke, so it's actually returning slower than it's cutting. So the return strokes are adding a lot of overhead. And it's going to be down on power because the quicker return stroke means that the ram has less leverage in that direction on the work. So it's going to stall easier, if you will, on cutting strokes if it's running in reverse. But it doesn't really hurt anything. The machine just is underperforming if it's running backwards. And like I said, it's clearly been running that way for a long time, but I'm glad that it's running the correct direction now. Like I said at the top, I'm doing everything I can to be a good steward of this machine so that whoever I pass it on to will have a tip-top machine to play with in their shop. Well, thank you so much for watching. I hope you enjoyed this little journey, and thank you to my patrons for making all of this happen, and I'll see you next time.